think today we're going to be talking about some external insulation, which is pretty popular in Canada, where both of us are from, but maybe a little bit newer here in New Zealand, where we are currently. Any fun stories or analogies or anything like that? How do you explain the benefits of, I guess, external insulation to someone who's never used it before?
Yeah, I mean it's not that old globally.
Sure.
From what I can gather, the most it sort of came about post World War II,
Sure.
and this was EIFS, EIFS, putting
External insulation and
finishing system.
Finishing system, yeah.
And this was EPS foam, expanded polystyrene foam,
Basically styrofoam.
basically styrofoam. And in post World War II, there was a need to retrofit a lot of buildings that had gotten blown up.
Sure. Or just like big shells and bullet holes and stuff like that.
Yeah.
Cover it with some foam, put some cementitious member or coating on top of it.
Yeah. So
and
if
then
you've
go
got
from
a brick building, masonry building,
Yeah.
and you put insulation outside of that,
Mm-hmm.
it's actually a really good insulative like retrofit option from that perspective.
Sure.
But also now you've got a brand new looking building.
Sure.
And you don't have to worry about piecing bricks together or something like that, trying to make them work. So
Yeah. Maybe fix the structure, but then you can just cover up all the gashes and big I guess blowouts or bullet holes and things like that. But so that's where it kind of started. Now, like I've gone back to Canada a few times, and a lot of buildings that I see are going up with external insulation. Why do you think we've kind of gone into that in Canada? Like, how did the ecosystem kind of evolve that way? What do you think?
I think in the probably 90s, 2000s, you started seeing a push towards more insulation in walls and roofs.
Building code changes or whatever.
Yeah, building code changes.
Sure.
In Canada is driven by energy efficiency, and
Sure.
New Zealand is driven by health, which is a very interesting paradox.
Yeah, interesting how that kind of...
Yeah, which you can get into a little bit later. But yeah, I think when you look at the like how much wall capacity you have to actually insulate, you're pretty much limited by your stud space.
Sure.
4x2s or 2x4s, 2x6.
So like 90s or 140s, and that's basically your two choices.
Yeah, basically, and even the financial trade-off between 2x4 and 2x6, you're starting to get into a space where that's not going to be necessarily the most financially viable option between those two.
Sure.
I think 2x6 sort of works out, maybe with wider stud spacings. When you get taller buildings and you get lots of studs in there, the whole thing falls apart.
Sure.
So it partly came from energy codes, probably also partly came from people actually counting how many studs are in their walls, which is just a thing that's come in New Zealand this year.
Being realistic about the actual percentage of timber between the insulation, I guess.
Yeah,
kind of
so
separating it.
our New Zealand's building code now, I think you have to assume 35% unless you prove otherwise.
Sure.
I think it's 35%.
That sounds right.
Yeah.
Somewhere in the
37%.
30s.
I can't remember the numbers, but
Yeah, somewhere in the 30s.
so I think people started actually counting and actually caring is probably where it came from.
Sure.
And then you look at, well, what if I want to go beyond that? Where do I have nowhere else to put insulation, and what can I do? So it came partly from those geometric constraints. Probably also came from product development.
Sure.
And chicken or the egg, which happened first.
Could be.
Certainly, EPS insulation's been around for, like we said, from post World War II, and probably something happened before that. But
Sure. I think in Canada, what I find is it seems like the easiest option to do external insulation for kind of a number of reasons. Here, we usually have the stick framed. You might put like a rab board on the outside, might put a membrane on the outside, and then you start insulating from the inside. But a lot of times the timber might be still wet, your concrete might be still wet. There's kind of things that have happened because of rain as they're going along. And it seems like enough contractors had gotten themselves into problems with that type of building that it became attractive to have, let's say, steel studs that don't have to dry out, and you put a membrane on the outside, your building's dry, you can start doing your interior work, your insulation install, and then you can put your insulation, which is weatherproof, I guess. Rock wool doesn't really get affected by moisture too much. Put that on kind of whatever you want. Put that into the cladding installer's bucket of things to do, perhaps, and it kind of takes things off of critical path. Possibly, maybe that's what kind of got
the sequencing work
popular.
one's interesting.
Yeah.
Yeah, I think people tend to see the cost of one insulation versus the other, the material cost. Doesn't really tell the whole story. There's there's a sequencing of work that happens there. There's an install component.
Sure.
There's a cutting and fitting between studs versus laying out large slabs of insulation. Those things all add up. I'm not saying it's for free, but it's not necessarily the delta of just the materials to look at. There's some cost savings the other way. You mentioned steel studs.
Sure.
And we opened this by talking about timber studs, but steel studs and concrete slabs are far more influential in that R value thermal bridging than people
Absolutely
account for.
Because timber's like similar to, maybe not similar to insulation, but it's, maybe 50% worse kind of thing.
Half. I was going to say half.
Yeah.
So if you built a solid timber wall, it'd be about half as a insulation only wall, which would be a weird wall to build, but
strange. But
you could build it.
Mass timber, I guess, like a CLT wall would be basically that.
Yeah,
just all timber.
When you get to steel studs, you're discounting that off-the-shelf insulation value by 70%.
Basically, yeah. If you're just stuffing the studs.
Yeah, and then when you start adding in these tall buildings that have steel studs, you start adding in concrete slabs that interrupt that insulation layer. Another probably 20-30% loss. So you're getting essentially zero R value.
Basically putting a bunch of insulation to do nothing.
It's doing absolutely nothing.
Yeah. Whereas, when people see this, a lot of thermal bridging out of a stud, the thing that I've seen as the quote unquote fix for that is those thermal isolator strips or whatever. Basically, 10 mils of XPS or something like that on the outside of the stud, which sure helps, but it's not really fixing the problem. You have to really widen it to make it work. So you might as well just make one continuous piece of insulation.
Yeah, there's a reason those work. And the reason they work is the calculation is a one-dimensional calculation.
Exactly.
So you're adding up, if you look up, what's the name of the thermal calculation? But the parallel path method, that's the one.
Sure.
Parallel path, you're essentially saying that you've got in studs, insulation, and the heat goes one-dimensionally through each of those things.
Temperature and relative humidity on the inside, temperature and relative humidity on the outside, and you draw lines between that where the temperature and humidity are going to be in the wall.
But that's just straight. There's no side-to-side.
Okay, sure.
In the thermal calculation.
I see.
Doesn't consider any side-to-side movement.
Got it.
Now, those calculations in the material, that's all done by laboratory testing. So when you actually build up that wall, and so if you try and circumvent that system by putting a piece of insulation
XPS,
in front of just the stud, well, the energy goes around it really easily.
Well, like you have your wall, you have the outside, you have the inside, you have your stud that's right over here. The energy goes all the way through the stud and just stops 10 mils behind the rab board kind of thing because of that.
So I like to explain thermal breaks and thermal bridges like a bridge.
Okay.
Say I was trying to stop somebody from crossing a bridge.
Sure.
And I'd put a roadblock up, a thermal break.
Okay.
If you put that thermal break in the middle of the bridge, there's a good chance you're not going to cross the bridge.
Sure.
If I put that roadblock 100 meters in front of the bridge on either side, well, people can walk around it and then cross the bridge.
Sure.
So to get an effective break, it has to be in the middle of the bridge, the middle of the insulation layer.
Sure.
Most effective spot.
And ideally, you don't have a bridge on either side of that is super, super conductive, like a metal of some sort.
Yeah, I mean, it could be a big bridge, like a metal.
Yeah, exactly. It could be a SHS or something like that.
Yeah, but so people get that wrong all the time. And then this is where external installations become a better solution, especially in those steel stud, multi-level, high-rise type constructions. Now, New Zealand's still using a lot of timber external walls for over...
Infill walls?
Infill walls up to 25 meters we're allowing here, which I think is, quite frankly, quite ludicrous. Unless you've got a tested system, it sounds a little bit risky to me.
Yeah. Technically it works, but there's risks involved.
The codes allows it, doesn't make it right.
Yeah, exactly.
Now, there have been some tests done on certain systems and in certain applications details, it's fine. But overall, we are trending towards steel on most buildings like the rest of the world has done.
Yeah, high-rise just makes sense. Steel goes up a lot faster, and you don't have to wait for it to dry.
And you've got zero combustibility risk.
Correct. And I think the key thing is putting external insulation makes things easier, and it kind of takes away a lot of the different different issues that you'd be in that you'd see. So with a steel stud, you have to go install all those thermal breaks. You have to kind of screw through the thermal breaks to get the rab board on, let's say. The slab edge might have to be a separate thing that also needs to maybe be wrapped, also might need some insulation in there. It kind of, there's all these extra little things. Whereas if you just build the building, build the infill walls with the studs, you put your rab board on, it's all weather tight at that point. After that, you put your insulation on, and it kind of hides all of the problems. Any variability in the wall can be taken up by that insulation. Any possible gaps or imperfections in your membrane are protected by a layer of insulation that prevents air and water from getting there. It kind of it adds that redundancy to the system without adding a lot of extra work and a lot of extra material. There is some extra material.
It becomes part of your cladding install.
Exactly.
Yeah.
One thing I noticed also is that a lot of cladding manufacturers, especially international ones, their typical installs or their installation manuals and their clips and things like that already accommodate external insulation, because in Europe and North America, that's already, I don't want to say standard, but somewhat standard.
The technology is not a limiting factor.
No,
the technology is here already. We've done probably, I don't know, a dozen buildings at this point.
Sure.
Middle of 2025 right now.
Yep.
At least a dozen.
At least a dozen, I think maybe more.
Yeah.
And a few in design right now as well.
I can remember when we first got here, there was 2 or 3 that I knew of.
Sure.
That had been built.
Sure.
And so we've probably got the lion's share of those now.
Yeah.
And that's been product availability that's helped that. It's been designers interested in it. I think a lot of designers and architects have known about external insulation for a long time.
Especially if they've worked overseas.
Yeah, but it didn't have the product supply here, didn't have the contractor capability or understanding.
Sure.
It's not particularly difficult, but just that uncertainty. And I think all that's changed. I think now you're seeing it as specified as one of the go-tos.
Yeah, I remember when we were first kind of designing buildings and hoping that we could use external insulation, we'd get the design done, QS would pick it up, they'd see it, and then put this huge price tag on it because they've never done it before, they don't have it in their spreadsheet, let's say. And I think we're starting to get to a point where people are more comfortable with it. Contractors at least have maybe seen it before or are excited to try it maybe, as opposed to
I think
scared.
5 years ago you were getting the material premium, which is real.
Sure.
Just the massive material.
Sure.
But then you were also getting an install premium on top of it.
Sure.
And I think the install premium's gone away.
Yeah. For certain contractors. I've had certain projects where...
If you've done it before, it's easy, yes.
Yeah, certain subbies will just put a big price tag because they've just never done it before. But
yeah. I mean, we've got lots of examples. It's a good example talking about the reduction in thermal performance from the steel studs. So we were working on a 5-story building, a social housing project, and needed to be steel studs for some reason I can't remember. Oh, it was program.
Sure.
They didn't want the delays if the timber got wet. They didn't want delays.
Sure.
So the initial wall buildup was sort of what you talked about earlier. It was about I think it was a 140 steel stud with a thermal strip on the outside.
Sure.
And then cladding.
Sure.
And the total wall buildup ended up being 300.
Sure.
And we ended up getting it down to a 63 steel stud.
Wow.
Thick gauge steel stud.
Okay.
75 mils of rock wool outside of that.
Sure.
Same total wall buildup.
Sure.
But 4 or 5 times the thermal performance.
Absolutely, of course.
So from our 2.5, I think we ended up building.
Yeah.
Versus what was proposed was actually our 0.75 or something like
Sure.
that.
Once you add up all the thermal bridges.
Yeah, especially once you add up all the slab edges and all those things.
Sure.
So
Sure.
and cost-wise, exactly the same, more or less. But save,
The key is having everyone on board with that.
we had early contractor involvement, right?
Yeah, that's always
like the installer was in the design room with us. Being
Sure.
like, yep, we can do that, no problem.
Sure, sure. And that's usually where it kind of falls apart. Like, talk about it nicely during design. Once it gets to a contractor and then they talk to their subby, sometimes, it just hasn't happened before, so they don't know how to do it. But that's when
We're getting pretty used to understanding where the resistance is, though,
Sure.
what you can and can't.
Usually you can circumvent that with a quick little meeting, maybe a mock-up, build some things, bring in some show and tell to show how easy it is.
I've just got to the point where, early in design, we're going to test or sort of see where everyone else in the design team is at.
Sure.
In terms of their technical abilities, their comfort level with something new.
Make a few suggestions, ask a few questions, and see how they react.
Yeah, get some feelers out there, see what kind of project it's going to be. And
Sure.
those projects which are gonna push the edge of performance, they're gonna get a lot of attention, a lot of hours from us. We're probably gonna lose money on them, to be honest, but
Almost always.
yeah. And then
But it's interesting at least.
the ones which are not interested in doing that, well, they don't need that kind of care and attention. It's a checkbox exercise, and
Yep.
and that's fine. It's got its own problems too, and its own attention, but
Sure.
yeah, it definitely does not get the same level of effort and interest.
Yeah, yeah. If the project team is just kind of going to things that have already been done before all the time,
Which
it's
there's
pretty
projects
typical.
where that's the right answer. Yeah,
Absolutely, there are. And for that, it's just like, yep, cool, details look good. Yep, we've checked this. Yep, cool. Here's your report.
that's what I meant. Yeah,
Whereas if it's a little bit more interesting, a little bit more strange, and it's always a little bit more fun for us, and we can provide more value to our clients.
Yep.
Because we're solving problems and saving money, making things easier to install, etc. So, yeah, external insulation. It's I think becoming more popular here. But do you think it's going to become somewhat ubiquitous like it is in Canada or the States? Is it going to become the kind of go-to? You think? What do you think?
low rise, no.
Probably not.
The
Yeah.
climate's so mild here that really a 2x6 framing, 2x4 framing, 4x2s.
Sure, with some insulation inside.
You look at
detail it
energy
properly.
models, and you're really not having much impact on energy bills.
Sure.
So I don't think low rise is going to really catch on with that.
Sure.
Definitely in the mass timber space, definitely in the steel stud and commercial space and high rise space, it's going to be the answer for a lot of projects.
Concrete structure too, where the structure's near the outside is always a good place for it.
Yeah, anything like that. But yeah, timber frame low rise, no.
Sure.
Which is the predominant amount of stuff we build here.
And I mean, like, that's also what we've kind of seen in Canada. Like, group home builders in Canada, are they doing external insulation? I've seen some,
Well,
like,
you're seeing it now in low rise,
Sure.
driven by energy codes.
because they've gotten up to a certain R value where you can't really get to it.
Yeah,
with,
so in
traditional.
British Columbia, step 3, I think most jurisdictions are on step 3. You're getting into like R24's kind of walls, R16 kind of walls, which
These
is
are imperial R, not
yes,
RSI.
yeah, yes,
Okay.
R3 to 4 kind of range.
Sure.
And you have a whole energy model that tells you what those kind of insulation values are. But
Sure.
I think some of those houses are trending towards that direction because they're getting, even at the best windows, you still can't get to those energy model numbers that you need for those step codes, which is fine. The technology is all there. And like I said, it's not that difficult for the average installer to install. So
Sure.
and then the flip side of that is you maybe save a bit on your windows.
Sure.
A really good wall.
Kind of balance it out a little bit. What I've also been hearing about from one of our former colleagues, John, is the external insulation as a retrofit on existing or old buildings, and that kind of ties us back to the European style of, after World War II, fix all those buildings from the outside. But we have a lot of older houses here in New Zealand that are, not doing so well. And I mean, like, this is common worldwide. It's not just New Zealand. There's older buildings.
Yeah.
How do we most efficiently make it a much better building? Because older houses, they worked, but they weren't necessarily super efficient or super comfortable, but they, lasted the test of time. How do we improve them without ruining them? How do we...
Got a bunch of different ideas on this.
Okay, let's hear it.
What you got to start with, what's the reason that you want to retrofit this building?
Sure. Recommend that for anyone who's like getting into a meeting, have that conversation early.
Yeah.
What's the client looking for? Hot, cold, comfortable, fancy? What's the...
I've seen it suggested that retrofitting buildings would be a climate change solution.
Okay.
That CO2 footprint, embodied CO2 footprint of the materials to retrofit a building
Sure.
exceeds the lifetime operational carbon by a gigantic margin in New Zealand.
Okay.
Because the operational carbon of the grid is so low in New Zealand to start with.
And so little heat is already happening, and so many,
Yeah, so
little
your
air conditioning.
carbon payback on a retrofit in New Zealand's never going to work.
Sure.
There are lots of other reasons to retrofit buildings. Carbon's not one of them.
Okay.
So don't. That's not a good solution if you're trying. If that's your only driver.
And I
Not a
mean,
great solution.
for the record, if that's your only driver just to save carbon, I feel like you're kind of missing some of the nuance. You're missing kind of the whole picture. Because carbon is a good thing to, I guess, reduce, but it's really just a marker or a flag or like a measurement for a bunch of other things.
Yeah, it can't be your only reason. Is what I'm trying to say.
Yeah.
So yeah, don't promote that as a good thing.
It fixes all the carbon. Yeah.
No, it's not going to.
Yeah.
Okay, so why would you want to? retrofit a building, particularly from the outside. Probably comfort. Probably comfort's going to be your number one driver.
For the record, not to disregard what you just said, but most of the times on my projects, the driver is they need to do a structural upgrade of the building, and then they're going to be cutting through some of the walls, and then they call us to say, how do we fix this? So it's usually that thing first.
So that's an interesting segue, or not segue, interesting point that it's happened in Vancouver as well, and other jurisdictions, I'm sure. But
seismic upgrades.
Well, it's the idea that when you touch one part of the building, you need to bring it up to as near as practicable.
Sure.
Now, in a lot of cases, practicable has been stuff all the insulation in the walls.
Sure.
In Vancouver, it meant that if you do an upgrade, you need to be step 3, step 4.
Okay.
In energy code.
So hugely upgrading the R values and things like that.
Yeah. So not just, or even if you want to do a kitchen renovation.
Really?
It's like the size of your reno was sort of indicate what you could.
As a percentage of your building or something.
Some of that,
okay.
Yeah.
Okay.
There's some negotiations involved, but let's say you were gonna add an extension to your building. Well, you might have to do something else to the rest of the building to get it to meet close.
Sure. Sure.
So that's an interesting driver that hasn't really been enforced heavily here. But
usually people go through Schedule 1, 112 kind of thing, saying it's just maintenance. We're just like for like upgrade, like not an upgrade or something like that. Usually that's the excuse.
Well, worse than that, New Zealand need a building permit to replace cladding.
Sure.
Or to insulate your wall.
Sure. And that's a whole thing that you have to go through council, get it approved, et cetera, et cetera.
Yeah.
But fair enough. Sorry to derail that. But you were saying energy upgrades is, or comfort upgrades is probably what people are looking for after the trigger comes from the structure, maybe?
What we see in research with retrofits of insulation is the energy bills don't change in New Zealand.
Sure.
What you get is basically comfort clawback. So what you would have, people have like their fixed amount they want to spend on heat for the year or the month, or whatever it is.
Yeah.
And that amount stays fixed. When you insulate, you're just making them more comfortable for the same price.
Either more comfortable at a certain time or could be also more comfortable over a longer period of time.
Yeah. Whereas in Canada, people are maxed out on comfort already because they have heating systems built in which keep them comfortable and thermostats to make sure that it's always the same temperature. So when you insulate in Canada, you actually might see a reduction in your energy bill.
Whereas in New Zealand, there are probably a lot of scenarios where we would see energy use go up after doing these retrofits because of the fact that you can now heat it or air conditioning it continuously. Which means that you're going to be spending more because you're running the thing more often.
Yeah, there's you could take the average utility bill across New Zealand, divide that by the average house size, and you can get a energy per square foot or per square meter intensity. Sure. And we're like 30 kilowatt hours per square meter. It's the average house across New Zealand. Passive house is 15 kilowatt hours per square meter per year.
So like you're almost at passive house already with just like a regular whatever bill.
Well, you're at passive house energy bill without the comfort.
Sure, exactly.
It's like a Temu passive house.
But I mean, like there's also Temu passive, little quick import fast fashion passive house.
Yeah.
But no, like it's an interesting kind of shift because the general I guess, way that people run their houses here in New Zealand is you leave it unconditioned while you're away from the house. You get home, you turn your heat pump on, be warm while you're, hanging out, eating dinner, watching TV, shut it back off, go to your bedroom. There might be a panel heater in there just for that bedroom. But yeah, it's a complete shift from Canadian style housing that I'm used to where the whole house is conditioned at a certain temperature 24 hours a day, 7 days a week for the whole year.
Back to the start of your point, though. Insulated from the outside.
Yeah.
So I think people, if they wanted to insulate their buildings now, they would drill some holes in the inside and blow some insulation in there. But
which technically does add insulation, but to me has risks involved because you're just kind of blindly adding it, and then there could be condensation issues.
There's all sorts of problems with that approach from a building science perspective. Overall performance, all of those things. So. Going to an external insulation system, so taking a rock wool, just kind of lay out the sequence of events here. So you've got your house, cladding, everyone's living in it nicely, covered in blankets and jumpers.
Sure.
And from the outside, you'll add a layer of rock wool or mineral fiber,
Sure.
to the outside of the cladding. You might wrap the cladding first, depending on what the cladding is.
I'd probably add it anyway, just for added weather tightness and air tightness.
Yeah. Okay. So let's wrap the cladding with something,
Cool.
then insulation,
Yep.
some sort of battening system, and air cavity, and a new cladding system.
Yeah.
All done from the outside, much the same as if someone was painting your house or
Sure.
recladding your house.
A little more involved than painting, but
Oh, it's
people
slightly.
don't have to move out, which is nice.
People don't have to move out.
Yeah.
Change the windows. All that can be done from the outside, and I think the net performance of that is going to be so much better than just spraying insulation into your walls.
Sure.
That you're now getting to the point where you probably would see energy bill reductions.
Sure.
You're into like the 90% reduction in energy bills and the comfort part.
The comfort is the
on
key
top
thing
of it
for
as
me.
well,
Yeah,
right?
yeah. But also, even in addition to like thermal comfort, putting a bunch of rock wool on the outside of your building will make your house so much quieter because that mass of that fluffy-ish stuff absorbs a lot of sound, but also deadens a lot of sound and doesn't allow it to come through. So if you can hear outside, you won't be able to hear outside once you put some external insulation, unless your windows are open or if you have like really kind of air leaky windows or whatever.
Yeah, if you haven't watched our episode on acoustics or you haven't filmed it yet.
Yeah, we haven't filmed it yet, but go watch it once we do film it.
Two things you need to know about acoustics. I took a course in university. All you need to know
Yeah.
is heavy stuff and fluffy stuff, soft sound.
Yeah, yeah. The heavy stuff will prevent the sound from going through a thing, and the fluffy stuff absorbs it from rattling around and echoing and stuff like that.
Yeah, it's
So-
otherwise pretty simple. It's far more complicated than that.
Yeah, but the nice thing is that the rock wool does both of those things. It is both massive, it has mass to it, and it's also kind of fluffy to absorb.
Give me your thoughts on PIR as external insulation.
It can work. I prefer rock wool because you get the density, which gives you that acoustic performance. It's fireproof. It's used as fireproofing material, like around really sensitive pipes and things like that. And so it has a few extra, I guess, advantages to it. Whereas PIR, it has a lot more, well, maybe not a lot more, but has a good amount more R value per millimeter than rock wool does if you're comparing the two. So you can have a thinner piece of PIR, but it is vapor closed, so you have to
That's the
worry
big
about
one.
the vapor thing.
That's the big one for me.
Yeah, you got to make sure you have the air tightness, the ventilation on the inside of your building, and enough thickness to prevent that condensation risk.
Yeah.
And so for me, rock wool just kind of makes sense because you're getting all those benefits and there's less risks involved. If you just put a bunch of rock wool, even if you do get some wetness in the wall, it'll dry through it.
Yeah, the permeability one's big for me. I think
Yeah.
we all want to keep water outside of the insulation side.
Yeah.
But if it does get in behind there, you've got drying one direction.
Yeah.
But
But you have to check on it. Whereas rock wool, you
Yeah.
can check less. You should always check.
Yeah.
Always check things. But there are certain assemblies that you can kind of trust.
a lot
because
less
you've-
sensitive.
Exactly.
Yeah, but there's certain applications over concrete's a great example
Sure.
where PIR.
Sure.
Oh, go nuts.
Go wild. Yeah, why not? The other thing with PIR, a lot of people are worried about is fire risk. But PIR isn't super flammable. It'll kind of char up. It'll kind of melt a little bit.
Not like mineral fibers, a lot better.
Oh, like yeah.
Yeah, a lot
So
better.
you've seen the demonstrations that they have at trade shows where they have like a flamethrower blowing at the rock wool, and you can put your hand on the other side. It's
Oh,
only
yeah.
like 25 mils thick.
Yeah.
Yeah. It's much better in a fire. But PIR is probably cheaper. It's lighter, easy to install. So yeah.
Do you remember? This is a side note. Do you remember a Canadian product that was a fireproof putty clay?
No.
Oh, okay.
Fireproof clay.
It was like I don't remember what it was called. I'm sure you can find the link for it somewhere, but it was like a
'Cause, like-
paste or a putty.
But like I've seen penetrations, like fire penetrations, and there's like a gray kind of stuff around that. Is that usually like a sealant, or is this the stuff you're talking about?
No, this was like a coating you put over something, and I'll find the whole backstory. But
Intumescent?
no,
Okay.
I'm not sure what it was.
All right.
Sidetrack. We might just cut all this out.
Interesting. If you know
remind-
what that is, you let us know. Put it in the comments.
So it reminds me of that blowtorch where you got like just rock wool and you got a blowtorch on it and
Sure.
you go through.
Yeah.
The guy has a whole like infomercial, the same thing, where he's got it like on a helmet, like a blowtorch. like
Was this a TV thing?
it was
I don't
like an
remember this infomercial.
Like was
Oh,
a direct to consumer product.
Interesting. But that really does go to show any suppliers who are listening, if you have some if you bring fire to a trade show, usually people will watch it. If you
yeah.
have videos where you're flaming
Or if you
things.
bring a product to Oculus, it will also see fire.
Absolutely. We generally like to burn things.
Very common to burn things.
Yeah.
First question is, does that burn?
We haven't burned things in a while.
I burned something last week.
Did you?
Yeah.
Damn.
Yeah, I had
missed
some
it.
foam filler piece.
Missed
that
it.
Was,
Fair. But fire, we'll talk about it at a different point. That'll be a different topic.
It was a fire-rated foam.
Oh.
It didn't tell you it didn't say what fire rated meant or what test it would done to. It just said fire rated.
Got
and
it.
I melted it with with a heat gun.
I see.
So it was not fire rated.
Okay.
Definitely not non-combustible.
Yeah. Do we know what kind of foam? Out of curiosity?
It was a PE foam.
Polyethylene foam. I haven't seen polyethylene foams really very much. Usually it's
I might have been
polyurethanes.
wrong. I might have been wrong.
No,
It wasn't going on our building. That was
Got it. That's fair. That's fair. Once you put the heat on it, it was gone. But okay.
What's your?
Yeah.
What is your? Talk to us about attachments through insulation, because that's been a big hang up for a lot of designers. How do I? Okay, now I've put insulation where my battens were supposed to go, and how do I?
Yeah.
What do I do?
Yeah. I'd say the easiest thing for many people to wrap their heads around is a clip with a batten. So you have your wall, you install a clip, you install a batten, you install your insulation. They're all kind of separately doing their own things. There's a load transfer pathway that's easy for everyone to understand. So that's usually the way that people do it. Here in New Zealand, we've seen a lot of like those Technoform clips with black plastic and an aluminium kind of channel. I've had some complaints from contractors about those because certain claddings need a very close spacing of battens. So you end up using so many of those clips. Whereas if you are using those clips, choosing a cladding that has wider spacings will save you money and make it a lot easier to install. That's probably like the easiest way. In North America, we see all those as well. Like there's the fiberglass post-extruded ones. There's metal ones.
There's
I think
like
Suprema.
20 now.
Yeah, there's a lot.
There's so many now.
Some of them have thermal breaks. Some of them don't. Some of them have like holes in them to reduce that thermal bridging. So that's one option.
There's three really in New Zealand I know about.
Sure.
Technoform being one.
Yep.
And then an aluminium one.
Sure.
And a steel zinc aluminum coated one.
Sure.
All is exactly the same thing. They're just basically a bridge in a kind of controlled manner.
Yeah.
And then a batten outside of that.
Point bridges with a batten.
Yeah.
The other option, some claddings, just the framing system that holds on that cladding already has all those things. Some sort of steel clip, some sort of other T profile, and then a batten across.
Yeah.
Sometimes there's vertical battens and horizontal battens, like a whole grid pattern, and then everything gets installed.
Yeah.
So that's kind of one option, clips, battens, and all that. The other one that is fairly common in Canada, I know RDH did like a whole study on it, is long screws through the insulation.
Mm-hmm.
So basically you have your wall, you have a substrate, you install your insulation on there, you install a batten on the outside of that, and then a screw that goes through the insulation into your stud, and the compression of that rock wool kind of keeps the screw in tension, which makes everything kind of work like a truss system almost.
Yeah, you've got tension and compression. So the way I try to describe it to people is if you were rappelling from a building.
Sure.
And you had a rope at some angle like this and your feet were sticking out that way.
Sure.
As you kind of go up the building and that tensile strength gets back, you can actually get to the point where you're 99 like that. And that's how it works. You've got compressive force of the rock wool in one direction and the tensile force of the screw. And it magically works.
Magically.
If you don't trust, build a small wall sample, stand on it, and you go, oh, god damn, it works.
Yep, it really, really works. There are, obviously, you have to have a certain compressive strength of the insulation.
Yeah.
You have to have the right size screws.
Yeah, you want to get up in the
100,
120 kgs per cube density.
Yeah.
That's where things get really good. You can get a lot of claddings to work at 80.
Depends on the cladding, though.
The math works at 80.
Yeah.
The problem is the installer and the compression at 80 is a little harder.
Because they'll over tighten, it kind of makes things wobbly, or what?
Yeah. Like with 120, you really struggle to get any gun to compress it at all, any screw gun.
You won't see any real dent in the insulation.
It's almost impossible to compress it.
Yeah.
So you can do it if you really try, but
80 or
with the
60
80,
kg. Yeah.
it's like you've got a bit of squishiness, and you end up with a little bit of that up the wall, which
Certain contractors might like that variability because
Yep.
instead of using shims, you just tighten or loosen,
yes,
possibly.
yeah. There's also special screws that are made for that,
Oh, really?
which you drive in, and then you can basically back them out to get the battens level. So there's
Interesting. Do
Yeah.
those exist here in New Zealand yet? Okay, cool.
Yep.
Just got to ask the right people.
Yep.
Interesting.
Rothoblast specs
true.
both have one.
True.
Yeah.
So yeah, that's a good option. The other question that I've been asked, we've talked about all the fixing ways, methodologies, right? I don't think there's any other ones.
Brick.
Oh, brick, yeah, with external insulation. Yeah, you're right.
Yeah.
So if you do want to do a brick cladding on the outside of that, there are prefab off-the-shelf solutions that can do that. So the first thing with a brick is you need to put the gravity load somewhere. If it's at the bottom of the building, you're putting it right onto the slab or onto a curb or something. But if you have a high-rise, mid-rise, whatever it is, usually you'll have steel shelf angles at each floor plate.
Yeah.
Now, when you're doing external insulation, you don't want that angle right up against your slab or up against your floor plate. You want to put some space. So what they have is these little kind of hanger C-channel clippy things. I'm not really describing them very well.
Standoff bracket.
Standoff bracket, that's the one.
Yeah.
And then this angle kind of clips into that or
Yeah.
hangs in it.
Now the
steps
poor
it
man's
off.
version of that is just put a RHS behind. So
Sure.
off your slab RHS, and then your angle in front of that.
Just a little chunk of it so that you have
Yeah, you
RHS, and then thing
Yeah,
across
you
the
can
front.
weld it together in the shop and
Sure.
angle through that. The thermal penalty of doing that is like 2% difference than the optimized standoff brackets.
Sure. But the standoff brackets, even though you're paying a little bit more, they have like diagonal adjustability to go up, down, or
they're
side to
sweet.
side.
I mean, yeah.
Tell us about it.
They're pretty sweet. I mean, you've got like post install adjustability.
Yeah.
They get cutouts, like they're CNC cut for like some cutouts. Yeah, they're pretty sweet.
Now,
But yeah, if you've the biggest one's lead time for those because they're custom CNC cut standoff brackets,
so you just have to get them ordered kind of after design, and then by the time you need them.
and they're heavy to ship. So they're if you're ocean freighting them, there's a 6-month lead.
Sure.
Whereas an RHS, you could probably get it into the steel shop drawings.
Yeah.
Same day.
Slice it off, weld it up
it's
in the
pretty
shop.
Easy, so.
Yeah. So that could be an option. But then what do you do with your brick ties? Because you have brick ties going all the way up the building for that, out of plane forces. What you also have is off-the-shelf product, which is like a two-part. Do we have one of those ties here anywhere?
Not on the shelf here,
not on
I
the
don't
shelf.
think. No.
But basically what you have is one bracket that gets attached to your studs, and then a wire that kind of fits into that bracket that acts as the connection to the brick. And that'll give you that extra distance for your insulation. Also gives you some side-to-side and up and down play for some seismic movement if you need.
Yeah.
So yeah, that's how you connect things.
Pretty easy solution. We've done a bunch of projects now with external insulated brick.
Yeah.
That's actually nice assembly too.
Yeah. The detailing is key. Simplification is key. I've had some of them where they're trying all kinds of funky aesthetic things and bump outs and this and that, and it just makes it a lot more complicated than it needs to be.
That's different. Yeah.
If this is your first time doing externally insulated brick, keep it simple. Keep your details fairly simple, and you'll have a much better time.
Back to the external insulation.
Yes.
Overall.
Yes.
Permeable or non-permeable membrane, and over or underneath the insulation.
Ooh, that's a very good question.
Yes.
You want my personal opinion?
Give us pros and cons of all those, maybe. Yeah.
So what I'm used to back home in Canada, which is what I find works pretty well, is a vapor closed wrap, and then your thick insulation on the outside. The vapor closed wrap will kind of circumvent that reverse vapor drive on a sunny day, which is key. But also with the vapor closed membranes, they tend to close around screws a little bit better than the non-vapor closed ones, the vapor permeable ones. So
there's not a huge amount of risk. I've seen some testing on that screws sealing, but it's better.
Yeah,
for sure.
Better for airtightness or whatever. But here in New Zealand, it is quite difficult to convince someone to put a vapor barrier membrane on the outside of their wall.
It's not even a fight I've tried.
Yeah, I don't even want to waste my time. I'll just put a vapor barrier, vapor permeable. And either way, it makes sense. But the other question.
No, arguably,
a
vapor closed, like a peel and stick,
would
perform better in that wall assembly when the insulation did get slightly wet.
Sure.
This is one of my.
Sure.
It's like the hypothetical. How could this wall actually fail? That's
Sure.
the only way it could fail is if you've got lots of moisture,
Almost saturated.
saturated
Yeah.
insulation. The vapor open wrap is going to stop vapor drive. It's going to slow down vapor drive, not stop it.
Yeah.
So it's gonna, the liquid water is not going to go through, but
Yeah.
if it is constantly wet on the outside, you are going to get migration through.
And I mean, you should be detailing your external insulation such that it's never going to be saturated. And with rock wool, for instance, if you have it on your wall, as long as you have gaps below it so that it's not sitting in a puddle, generally it's probably going to be dry.
This is an extreme hypothetical.
Yeah, of course, of course. If you have like airflow in your cavity, your cladding cavity, then usually you'll be fine.
Yes.
But
Yeah.
but there are ways to do it. The other question you asked was, do I put the membrane on the substrate or on the outside of the insulation?
Yeah, I've seen solutions that do both, including in Canada too.
Sure,
It's
same.
not exclusively one part or the other.
So my preference, once again, this is a personal preference. There are scenarios where it might not be the right choice. I would put my vapor closed wrap on the building first, gets me fully watertight, start doing whatever you want, put the insulation on the outside, and then cavity and cladding. But there are certain scenarios where, let's say you have like an open jointed cladding and you need the joints to be dark, let's say. I've seen, rock wool with like a black wrap over it just for that aesthetic purposes.
I've also seen black paint in that.
Black paint on the rock wool?
Yeah, yeah.
They just roll it out. Okay, that's one way to do it. But yeah, if it was a different type of insulation, a much fluffier insulation, lower density, maybe I'd want to put the wrap on the outside, perhaps. If I was worried about a lot of water coming into the joints, maybe I'd put it on the outside. But rock wool's pretty good at dealing with water and drying itself back out, so usually I wouldn't wrap it. How do you feel? Same?
Yeah, I'd agree with you there. I've seen applications with wrap over top of the insulation, like on the outside of it, and
Makes sense if necessary.
it wasn't something I'd used to, but I sort of looked through them. I'm like, yeah, it's probably fine. Like, it's different than what I'm used to, but there's nothing inherently wrong with it.
If the science and the math make sense, then why not?
Yeah, there's a sequencing question for sure.
Sure.
But yeah, overall, I think either one could work.
Sure. The last question that I usually get about externally insulating is how to attach the insulation itself. So if you are using the long screws with the battens, the insulation gets held by the battens and the screws. But if you're using those clip systems, if you're using a vertical, horizontal batten frame kind of thing, sometimes that insulation is going in by itself. What do you usually recommend to attach the insulation if it's not being held by the frame?
I've got a good story about these actually.
Oh,
So the product or the type of product is called stick pins.
sure.
Or you can get screws with washers.
Sure.
Stick pins are probably the nicest way to do it.
Okay.
It's an adhesive plate. Stick that to the wall, and it's got basically a wire coming out.
Sure.
Shove the insulation on, and there's a retainer washer.
Yeah.
And you're sort of
Basically
done.
stabs through the insulation and you put the washer on it.
Yeah. So my first project, actually, one of my first projects, had stick pins in the back of a window wall back pan.
Okay.
And it was installed in the factory with insulation there. Stick pins were sticking out. And when they came to install the windows, those stick pins were in the way. So instead of cutting the stick pins, they took all the insulation out, which happened to be the fire stopping for the building.
Perfect.
And no one really caught that for 24 floors, and they had to go back and cut through the back pans and retrofit it.
No.
As they're cutting the back pans, they're using a grinder, and that sprayed steel shavings all over the windows, and the steel rusts, and it was
Oh no. I see.
it was a bit of a debacle.
Yeah.
We got there in the end. Certainly not the biggest debacle I've seen, but
If you are a contractor, let this be your warning to watch your subbies when they're doing things, and just make sure that people aren't making kind of
Site
game
modifications,
time decisions. Just like let's cut some things out to
that's
make
a
my
tough
thing
lesson
fit.
learned.
Yeah, unfortunately, but
But yeah, stick pins be quite good. Screws with plates, there's lots of like plastic kind of screws and washers, which
Yeah.
work fine, but it's not. Usually the battens hold a lot of that
yeah,
pressure in there.
I'd say my recommendation is if you can get the battens to hold it, or if you have the clips and the clips can have a washer that goes on the outside that holds onto that thing, much easier than putting separate.
Yeah, the brick ties we were talking
fixings.
about earlier do that as well.
Yeah. I had one project where we were using the stick pins because of the fact that it was over a concrete substrate. And I believe it was the membrane manufacturer that did not want us to use the long screws with the washer on the outside because they couldn't check the concrete that it wasn't cracked behind it to hold everything. Which, sure, fair. Things to think about, I guess. And so, yeah, that's when we got pushed to stick pins. But also, they didn't want to do adhesive ones. They wanted them to be screws.
Can't be fixed, yeah.
So they put the stick pin on with a screw, and then they put the insulation on. So
Yeah.
ideally, don't go through that many steps. Get it sorted out in design. But
You're not really going to get a lot of suction force on the insulation.
Yeah, exactly.
Anyways,
because the cladding's in front of it anyways.
it's mostly going to be on the cladding.
Yeah. The only time it might make a difference is if that insulation's going to be exposed for a bunch of time before the cladding goes on. Hypothetically, maybe they got to put something on, but
Yeah.
not something you find in design usually. That's
Yeah, I mean
construction
the modern interpretation of external insulation is probably 30, 40 years old.
sure.
And I haven't heard of any case study of insulation falling off a building
Me neither.
or even getting wet or causing failures, anything like that.
Me neither. Just as one quick aside, I've had conversations where I suggest external insulation, and there are some people that don't believe it's possible because instead of seeing how Rockwool works, they imagine fiberglass bats and wrapping a building in fiberglass bats.
Oh yes, yeah, yeah.
External insulation is not that, or it is that? I'm just kind of throwing you an easy one over the plate here.
So it's much more. So external insulation is a lot more rigid than that.
Yeah.
It's if you took 200 mils of bats and squash them together to like that,
Sure.
that's more the rigidity that it is.
Sure.
It's like it's thicker. It's stiffer than like a camping foam. Foamy.
Definitely.
Yeah.
Stiffer than even like a memory foam that you would put on your bed or something like that.
Yeah.
It's like, I mean, we have a piece kind of right here that is almost the same. I'm just going to go like
It's
this.
not far off. There's some up there.
Yeah. Man, it's kind of hidden behind there. But, it's a rigid board. And you can do that with Rockwool as well. You can hold it up like this.
Yeah.
So, yeah.
But there are also external products which are lower density, like the 40 kgs.
Sure. I've seen some fluffy stuff.
Yeah, you can use some fluffy stuff. That's fine. Look for something with some sort of barrier that prevents wind washing through it.
Yep.
When you get to densities, I think 60 to 80 kgs, the wind washing effect goes away because the air.
Once it's butt up, yeah.
Yeah, it's just all it's too dense for air to go through.
Yeah.
But if you're going to those 40s and below or in that range, then you want some sort of barrier outside to prevent that wind wash of getting through your insulation.
Yeah.
But there's nothing inherently different about a lightweight or a low density insulation.
What I found is that some of the lower density stuff that is rated for use outside sometimes has a different binder in it that makes it a little bit more water repellent.
Yeah.
Sometimes like the way that they wrap it together or extrude it together also prevents water from going through.
I think
Whereas
some of that's marketing.
but it probably is. This is what they tell us at least.
The water,
But
it's a lot of the water repellents are marketing.
Sure.
Inside a rain screen cavity, you've got drying. You're not going to water there very
Exactly.
often anyway.
It shouldn't be any liquid water sitting in a puddle of any sort.
Not really.
Shouldn't
No.
be designed that way. So.
Yeah.
Interesting. Okay, well that's external insulation. It's just as a kind of a wrap up here. It's not as difficult as it might seem. If it's your first time doing it, let us know. We're here to help. We'll kind of point you in the right direction for the right people to ask for certain products and
Not
things
just
like
us
that.
in New Zealand. There's
No,
lots of designers and
Absolutely.
and manufacturers and installers that have done this now. And
Yep. You can Google it now and find a local New Zealand source for that stuff.
yeah, and almost every cladding supplier has heard of it.
Yep.
And probably has some ideas of how they would do it.
Yeah.
So it's definitely not new anymore.
Yeah, and I'd say in terms of making decisions on all the stuff that we talked about, how it's being attached, what cladding and stuff like that, I find it's always best to have the contractor and the installer involved, because instead of telling them how to do something, you ask them how they'd like to do that, and you can guide your design towards that. And I find that it kind of gets everyone involved, responsible, feeling like they're part of the decision-making process as opposed to being told to do something that they don't know how to do.
Yep.
But yeah, any other tips and tricks for external installation?
No, I don't think so. I think it's going to become more popular here as we go, and we've already seen a pretty rapid uptake.
Yeah.
And we've got suppliers now which have a lot of us in stock, which is was a big holdup
Sure.
5-ish years ago, which is
Sure.
not the case anymore. There's tons of stock of these products available.
One last question.
Yeah.
Getting it consented. A lot of people previously might have been worried about that, but we've been getting a few more consented recently without questions.
I have not had a question about it, to be honest.
Really?
Yeah.
Okay. I've had a couple projects where we've gotten a bunch of RFIs and had to kind of work through that process. But recently, yeah, it's been, I think even council has wrapped their head around it and sees it as a viable option, which is good.
Yeah, I think maybe the first couple there was like some generic like how does this comply question, which is usually like they've just never seen it before.
Sure.
And that's why they're doing it. But when you get into there's tiers of council permit officers,
Sure.
or consent officers.
Sure.
The ones in the commercial space have seen this a lot now. They're not risk adverse to it. The ones that are on like the single family homes, they wouldn't have seen it before. They would
Sure.
be rightly out of their sort of depth or their area of understanding.
Be asking questions that we have to go answer afterwards.
Yeah.
Makes sense.
But coming up in May of 2025, I'll be speaking on this topic at the Boynes conference.
Nice.
I don't know if this episode will come up before or after that. But yeah, a couple other tips and tricks from that, I'm sure.
Yeah. Be an interesting thing. And as we keep going and as more buildings get consented and built, it gets easier and easier. Everyone gets more and more familiar. So yeah, if you're ready to do an external insulation assembly on your building, give us a call. We'll help you out, or we'll just point you in the right direction. You can do it yourself, and yeah, all good. Not sure how else to end.
That's probably good.
Cool.